let's look at trig identities. And the ones that you guys are working with in grade 11, and there are actually a ton more. But what you'll have to work with is reciprocal identities, quotient identities, and Pythagorean. And I think on the list your teacher gave you, it's a little smaller than what we have here, and there's a reason for that. This concept here, you really only need to memorize these three, and as long as you know fraction rules, you can, I guess the best word is derive these from those ideas. Same with this quotient identity. This is the easiest one to show you that idea with. Tan theta is equal to sine over cos. Okay. Well, cotangent is the reciprocal of tangent. Okay, 1 over cotangent is equal to tangent. So what that means is, it's kind of like an idea of 1 over 5 is equal to x. So if I were to ask what 1 over x is, okay, I would invert these. I would flip these two concepts over. Did you guys work with Sine Law at all last year? Yeah, it's the same idea as Sine Law. Maybe that would have been a better example. If you remember, Sine Law is something like this: sine of an angle over a side, sine b, right? And then technically there's a c with it. Sine Law can be just flipped, and everything is technically the same. I can write it as a over sine a is equal to sine b over, whoops, I wrote that upside down. Sine b would be on the bottom. B over sine b. And this is completely fine. The idea is that if you flip one side of a fraction, as long as you flip the other side, everything is still equal. So, with that idea, since these are reciprocals, if I was to flip sine over cos, okay, and I put cos over sine, that's equal to 1 over, oops, don't disappear on me there. That's equal to 1 over tan theta. So this flipping rule lets you kind of find a whole bunch of extra things, so it makes it a little easier for you to memorize less information. As long as you know these flipping rules, you can find a lot more stuff, okay? So with that being said, let's actually deal with this question. So we're ready to get our example. It said sine theta multiplied by secant theta is equal to tan theta. Okay, so usually the way we write things or we talk about is of a right side of an equation and a left side of an equation. And the balance or the middle of that is considered the equal sign. So anything, oh, I wrote my left and right backwards, but this would be our left side and this would be our right side. Okay, it's a good thing about computers. Can fix that really quick. Okay, and like I said, the equal sign is our middle here. So what we usually go about trying to prove is we go about working with proving that one side is equal to the other. So you usually just work with the left side, and we slowly manipulate it till it eventually becomes tan theta. Okay, and that obviously tan theta is equal to tan theta, and that means therefore they are equal. Okay, so let's work with the left side. We'll start with this, and this is actually a relatively straightforward one once we get into it. We'll work with the left side and prove it, and then technically that's enough, and then we can do the reverse and work with the right. Okay, so we have sine theta times secant theta. So we go back up here, and usually these are the three you're used to working with: sine theta, cos theta, tan theta. These are a little new to us. Okay, secant theta, cosecant, and cotangent. Have you talked about them at all?
Kind of.
Kind of? Okay. So cosecant is the reciprocal of sine. Secant is the reciprocal of cos. And cotangent, obviously, is the reciprocal of tangent. Okay. So what they've also shown you is cotangent is equal to 1 over tan. That's that flipping rule I was talking about. It's the same idea here. They just inverted this fraction. And technically, we can write this as a fraction like tan over 1. So we invert that, and as soon as we invert, we can memorize things that way. Okay, so we had sine, so I know I can write sine as 1 over cosecant, but I don't know if that's really going to help me get to tan. The other thing we're working with is secant. Secant can also be written as 1 over cos theta. So let me see if that'll help us, because I'm already starting to think about this quotient identity. I know that tan is actually equal to sine over cos. So I'm going to try to write everything in sine and cos. I'm going to see if getting to my quotient identity will help me solve. So we kind of almost have to think ahead before we start to work. So with that being said, I'm going to replace secant with this part right here, the 1 over cos. Okay, so let's replace secant theta with 1 over cos theta. Okay, so what we didn't write is what we changed. This is still sine theta. And like I said, we're just going to leave the right side. You can write the equal sign in again, but the whole focus is trying to get the left side to be equal to that. So fraction rules, well, if we're to multiply, this is still multiplication. If we multiply fractions, we do the top by the top and the bottom by the bottom. 1 times sine theta is just sine theta. Okay, and 1 times cos theta is just cos theta. Okay, and according to our quotient identity, sine over cos is equal to tan. So I know that this can now be replaced with the idea of tan theta. Now, if they're very, very specific, they might tell you to reference what rule, like maybe we used the quotient identity. So on the left, you could say I used my quotient identity to go from here to here, but I highly doubt your teacher actually wants you to do that.
Yeah, I don't think so.
Yeah. So that proves that it's equal to tan theta, okay? And that's it. That's a proof of an identity. With that being said, we could have technically worked the other way, though probably visually a little more difficult to do. So I'll rewrite that question out again. My writing's a little sloppy. I could have started with the quotient identity, that idea of tan is equal to sine over cos, okay? So let's say, again, you don't need to normally reference it, but I'm going to just put it for your note, okay? We're going to work with the right side here. I almost wrote that backwards again. And we're going to change this into sine theta over cos theta, according to our quotient rule, okay? Then I'm going to split this, okay? And think of it like we've common factored, okay? We've kind of common factored out the sine theta. I'm going to write this as sine theta over 1 multiplied by 1 over cos theta. This is still technically the same as above, but a little harder to mentally do. This is like the factoring of something, okay? Does this step make sense? Are you okay with it? Yeah. Okay, so now I have that, and well, on my left side, sine, okay, check, we have a sine. Secant, well, I know I can manipulate cos. 1 over cos, here, is actually equal to secant theta, so let's replace that. We're going to replace this 1 over cos with secant theta. Okay, so we've just replaced this part. And we left this part. We don't need to write over 1 because by dividing something by 1 doesn't change anything. So it was sine theta. And lo and behold, the left side is now equal to the right side. Okay, now this is actually a really, really basic one. I'm just showing you can do 2 different ways. Some people will, and mathematically a lot of times your teacher will tell you not to do this, but as a strategy, sometimes you get stuck. Okay, let me zoom in again. Let's say I got to this part here. Sine cos, and I just couldn't remember where to go from here. Some people will start working on the right side until they get to that. Okay, now they ask you, a lot of times math teachers will tell you, I don't want you to do that, I don't want you to work on 2 sides. But as a strategy, it's not a bad idea. If you get stuck, start working on the other side. And then if you get something that's equaled, okay, you can just take your steps and bring them down here so it looks like you only worked on 1 side. And maybe I'll show you a different example of something like that. Okay, this one's too few steps to kind of implement that strategy.